I think I was in your first cohort as well, and I was got a lot of great questions, so I'm hoping for that today as well. I think there was a Slido link posted on your Slack, so you can get your questions in. And I'm Joe. I work at Vespa, and I'll talk about what you see is what you search, and using vision language models for PDF retrieval. Yeah, so I'll give a quick introduction, talk a little bit about indexing and searching PDFs, quite popular for RAG to handle PDF formats. It turns out a lot of important information in those document types. Talk a little bit about vision language models. Most of you probably played around with them. Then I introduce you to ColPali. So that's a retrieval model that's based on using vision language models, and talk a little bit about scaling that to larger collections in case you have millions of PDFs, a little bit about RAG with VLMs, and then some Q&A so you can ask all the questions. PDFs is like messy, right? There's a lot of different formats, exporter tools, lots of different information, layouts. Some of these even aren't really text, they're just an image embedded in the files. So that's kind of challenging. So it's always been fascinating to try to build search over PDF documents, right? And it has also a lot of like really important information in the visual clues, tables, charts, and as I said, embedded images. And of course, when the whole RAG wave hype started, there were like lots of demos like chat with your PDFs. So it's kind of been popular for some time. So you need some kind of extraction pipeline here to extract data. For example, if you want to use text search or embedding based search or any type of search solution, you typically had to transform your data into text. But this process is quite messy. There's probably like hundreds of different tools that tries to extract information out of PDF documents, but there are several issues with it. For example, embedded images. The whole thing here in the yellow line is actually an embedded image. It's difficult to extract that information without having a OCR type of pipeline. Also, typically the ordering and the layout or the font size that could emphasize the importance is not really well extracted when you use at least some of the bad PDF parsers. It's like example of the nice looking document on the left side and the right side after going through a rough text extraction routine. So the whole kind of the first word here, sustainability, is not like the first word in the extracted text. And that can have like impact on embedding search or even text search like with PM25. In any case, why are we extracting the text in the first place? So why are we doing that? And that's because historically you had to do that in order to use a text search engine, right? And if you're using like a text search engine like Elasticsearch or Respa or anything, you still have to map the text data so that you can use a text search index. And now with more popularity around embedding-based retrieval, vector database, and so forth, then you're in addition embedding the text, right? And then there's a lot of different other models, Burst, Blade, OpenAI, lots of different models. And also such an interesting area where there's a lot of money and a lot of investment in extraction, right? There are a lot of technologies. There's a well-known project called Apache that is handling multiple different formats. There are several companies, right, funded to solve this problem. You have unstructured, then you also have from the hyperscalers, you have different type of solutions. You have Llama Cloud. So it's like really hot area. But it turns out that vision language models are also pretty good at reading screenshots of PDF documents. And vision language models, I think, was the most exciting development in 2024, like last year. And so much happened. And really, I would say, dramatic progress. And broadly, like VLMs are defined as this multimodal that can both take text and image as input and then generate text, right? So you can give it an image and ask, for example, what's in the image, and then have the model answer. So there's a great introduction blog post from the excellent Hugging Face team linked here. I will share the slides with Jason afterwards so you can link it up to the course material so you can click on the links. And also the frontier models like GPT-4, 4.5, Gemini have really great vision capabilities. And I talked about last year, 2024, there was like a lot of progress, right? The early days, they were like able to search for cats on the internet, and you're doing embedding-based retrieval. Then OpenAI came with a vision-capable model. And after that, the last part of 2024 was just wild with lots of different models from providers, closed source, also open source alternative. We are, by the way, 2025, this slide I made last year. Accuracy is like different types of tasks, like image classification or OCR type of tasks. Lots of progress on this. And one of the models that was released last year was Polygamma. And this was Google's kind of cutting edge, open weight, not open source, but open weight visual language model that's been trained and have this kind of OCR capabilities. You can, for example, use it for question answering. On the right side here, there's a demo from a Hugging Face space demo where I've given it a screenshot, a PDF page, right? The entire page in a PDF. That's one input. The other input is a question, like what is the percentage of produced water that is reused? Then it reads this information and comes out with the answer. But that's given one page. And I think this, for example, is also using an open source model from Qwen. And similar, I give it an image. It's quite advanced. And I think I asked it, like, what is going on in this image? And it outputs this and it explains the image in a really well way. Because this is like I take to my manager and say, hey, you know, we did this optimizations, you present this data. It's really a lot of things going on here. And the VLM basically perfectly explains what's going on in this image. It compares these lines, identifies what they are. It also says that the latency have decreased a lot, indicating improved performance. And that's exactly what this graph is showing. So I was mind blown by all the progress VLMs had in the last year. Then talk about ColPali, and the researchers behind ColPali realized that we have these really powerful VLMs. So maybe we can try to replace the text-only embedding models, right? So OpenAI embedding models or Cohere, previous generation text embedding models that takes some text input and then produces a vector representation. What if we can just take a screenshot and use the VLM as the kind of backbone to produce the vector embedding? They also argued that in this industry, right, you have all these kind of messy PDFs, and the performance bottleneck is typically in the extraction process, not so much in actual choosing the embedding model or BM25. And I think everyone that has tried to do PDF search can testify that extraction is really important. But with ColPali, you essentially bypass all of this because you're not going through a text extraction routine. So they illustrate this in the paper on the top here. They said, okay, you have a PDF, you have to do text extraction, and in order to identify if there are embeddable images, things that you can't extract text from, you have to do OCR. And also you would like to do layout detection to figure out where the elements are actually laid out on the page. And then you can put this into a vector database or a search engine that has this capability and then perform retrieval. And they say that, okay, let's just take a screenshot of the page, give it to Polygamma, obtain some vector representation, and perform a similarity calculation over this data. So that's, for me, when I saw this, it was like, wow, what? Are you just embedding the screenshot of the entire page? Like, you don't have to do the text extraction at all. You don't have to deal with chunking. There's probably millions of hours worth of videos on YouTube, right, dedicated to chunking, chunk size, split size. whatnot, right? And here it just bypass that. So I was like really intrigued when I saw this paper. And ColPali is short for contextualized late interaction over polygammas. That's a lot, right? So let's try to break that down. It builds on two concepts. It uses the embeddings to obtain multiple embeddings out of one page. And that's the contextualized embeddings. I'll give more concrete examples here, but take the screenshot of the page and obtain these multi-vector representations. And then similar for a text query, you do the same thing, and then you also obtain multiple vector representations. And then there's the late interaction part here. You can do both of these like independently. And the scoring is about the late interaction between the representations of the query text versus the page screenshot. And I can call this like a bi-encoder architecture because of this, because you can take all your PDFs, run them through this model and obtain the embeddings, and then do that offline. And at the online stage, where there's a user using your system, you encode just the query and you don't have to encode the document. So that's kind of why it's called a bi-encoder, or a two-tower is also popular to call this type of architecture. But one core difference from embeddings from Cohere or OpenAI is that here you have multiple embeddings representing the query text, and you also have multiple embeddings to represent the screenshot of the page. And to summarize ColPali, what's the key things about ColPali is that you can perform this kind of matching and retrieval without actually doing text extraction. You avoid an OCR in your document processing pipeline. You don't have to do any kind of layout detection. So it greatly has a great potential to reduce the complexity of your document processing pipeline. And also, as the paper demonstrates, is that you can also get better relevancy, at least on this benchmark that they demonstrate on. And I think it's like really strong future direction, because you avoid all this complexity. And it's also is a method that generalized to a lot of different formats, right? So essentially, can you print it? You can also search it, right? So I think that's very powerful in terms of like, if you can render it on the page, operator from OpenAI and things, what you're seeing on your page and the text, if you can screenshot that, run it to ColPali, it's essentially searchable, right? Without having to deal with different types of formats, you're just taking the image. So let's go a little bit into the real details of ColPali. The underlying vision language model takes a screenshot of a PDF page, not the whole document, but one page at a time. And it essentially divides this image into what they call patches, but you can also think about it like a grid cell. And one page essentially is 1024 cells. And each of these cells or patches are represented as a vector, 128 dimensional vector. And if you, for example, do a text query with you also, in addition, they do add a prefix. So it turns out to, from 2024 into 2030 vectors, because they add a token prefix, which is describe the image. Then they obtain the embedding. So this is kind of illustration that each of the areas or each of the cells are represented as a vector. And you do this on a per page level, not the whole PDF. So if you have one PDF, you first extract all the pages, and then you run each of the pages through ColPali, and then you obtain these multidimensional tensor with 1030 vectors. And on the query side, you run it through the same vision language model. Remember, you could both input text and image. And there you also have the same dimensionality. So each of the query tokens are in the question or query is converted into a 138 dimensional vector. This is the same. And they also do some kind of query expansion there to expand the query. So you have slightly longer. Also, it's actually tokens. So after you tokenize the input text with the tokenizer that is associated with this polygamma model. in the bioencoder architecture, you have the document side representations and then you have the query representation. And the scoring is what is referenced as the kind of late interaction. And late interaction was actually introduced 5 years ago by the same author of the DSPy library. And the benefit of this is that this kind of scoring mechanism is easier to train to learn this kind of representation. And it takes, I think the next slide actually explains it a little bit better, but you do a lot of dot products between all the query tokens and all the patch embeddings. And then you take a sum over all the query tokens. So this tries to illustrate the maximum similarity function that is used, and it's called late interaction. It essentially calculates a similarity matrix between all the query token vectors and all the patch level embeddings, and finds the maximum patch similarity per a query token. In this example, we say that, okay, we have 4 patches with vector representation, and we have 2 query tokens. And then so water here is represented as a vector 1, 4, a 2-dimensional vector. Then we calculate the dot product between the water vector with all the patch vectors. So that in this case is 4 dot products. And then we pick the maximum score to represent the score for water. And then we do the same thing for recycle. There's a different vector, and those are contextualized. So if you change the order of those words, the vector representation will be different. Same thing, you calculate all the dot products, and then you find the maximum, and the final late interaction or maxim is the sum of these two. And if you have 6 query tokens, then you will have to do this process like 6 times. So that's the kind of overview. The great thing about this is that it gives you explainability on a per query token basis, right? If you map everything of the entire page into one vector and all the query tokens into one vector, you can simply just say something, okay, it was retrieved, we have no idea why, we can just hand wave in the direction of how the model was trained. With this late interaction or maxim, we can actually inspect what are the areas of the page that each of the query tokens attended to in the scoring. So it gives you also, in addition to being a quite good retrieval model, it also gives you the expert aspect, which can be handy in some cases. And then theoretically, you just perform this. If you have a collection of PDF pages, you score all of them. It's the same process as you do with a regular search, right? But there are ways to optimize this kind of process using different types of techniques. But you have this scoring, right? That you calculate the maxim for this page, for this page, for this page, for this page, for the same query input, and then you essentially just sort them by this score, the late interaction or the maxim score. That's essentially the same thing that you're using with Elasticsearch or Vespa or others. You're scoring these documents, and the score is a proxy for the relevancy to the query. Then there are techniques to accelerate this to avoid having to linearly score all of the documents in the entire collection. And so where did these vectors come from, right? When you have the polygamma model, you have to have label data to train these representations. So what the authors did in the paper is that they took the polygamma model, the base model, and they froze it, meaning that during training, they don't update the parameters. Then they have this adapter, almost like a LoRa adapter. And that's what is trained during the training process. And this kind of updates the weights. But in order to do this, you have relevancy, and the relevancy data is typically a query, a page, and if that page is relevant to the query or not. And then you have typically 10 to 20,000 examples like that you can actually train. And this also gives you the possibility to fine-tune polygamma for your specific domain, potentially using synthetic data. And how does this compare with traditional methods, right? Chunking, BM25, vector search. And they also introduced this ViDoRe benchmark, where they compare with different other types of models on different types of data sets. This table is a little bit, it's a handful, but you can notice, for example, the blue highlights data sets that essentially regular text extraction methods doesn't work at all, because these data sets contains infographics or embeddable images that you are not able to extract text from. So in the result table here, they compare a traditional keyword search scoring mechanism, BM25, that you will find in historical search engines, and compare it with a relatively good embedding model from BGE called M3. So you get some numbers there for NGCG. Then they compare using both text extraction plus OCR. Then you can see that you suddenly get results, because then you're able to extract some of the text. The bottom line here is that ColPali outperforms these different types of methods on these data sets, and with a rather large margin, I would say. And then on the right side, there's like these different data sets. They're not so big, so it's like not millions of pages. And also so most of the data sets have like 500 documents. So that's a weakness, I would say, with the benchmark. But in terms of relevancy, you go from, with text extraction, you go from NDCG score of around 6.6, 66, and you go to 81. So that's a rather significant improvement. Even for the data sets where BM25 and embedding model is also doing quite well. If you, for example, look at health, you can see a standard BM25 gives you 82. But ColPali, that is just operating on the visual representations, gives you 94, right? So even if you don't have a lot of figures or things like that, it's actually working pretty well. But still, this is on your data set, on this benchmark. You have to figure out how it performs if you want to overlay it on your task, on your domain. I think that's important. And these are some samples from this benchmark, like what type of documents are in the samples. Gives you an idea of what the data looks like. Right? So it's quite complex, some of these documents. More samples. So there's like a big mix of PDF pages. There's some of them are clearly like scanned records, even with handwriting. And some are like fancy financial reports with lots of different visual information. Yeah, so it covered like VLMs, ColPali. I talked about the scoring function. I can talk a little bit about how to scale ColPali to if you have millions of documents, right? Because as we said here, you have a lot of vectors, right? Because each of the pages are represented by 1030 vectors, right? So that's a lot of vectors. And this is the math involved in the ColPali maxim calculation. So they compute, because you calculate all these dot products, it's quadratic, right? Almost like the attention mechanism in a regular large language model. The storage part scales with the number of documents you have times the number of patch vectors and the vector dim, right? So these are the kind of parameters. And of course, you have to do inference as well, but I ignore that. You have to run inference with the actual model to obtain the vectors, but I usually deal with the things that is after that, so I ignore it. So there are a couple of things you can do to scale this. You can reduce the number of patch vectors, then you don't have the explainability feature, because then you're saying that in an image, there's a lot of areas that is not really important, that is white, that is overlapping. So you're basically clustering them so that you can represent one page with fewer vectors. You can also reduce the position of the vector. So you have, in the normal way, you have a lot of float vectors, 4 bytes per value. You can reduce this, and that reduces storage. For instance, you can use a bit even. Instead of a full float, you can use a bit. That gives you a 30x reduction in the memory or storage footprint. You can also scale the compute by replacing the float dot products with a binary similarity matrix, meaning, for example, using an inverted Hamming. And this also improves compute by 4x. So that's how you can kind of scale this and make it more efficient. And this compares kind of performance latency using float representations versus using bit representations. So you can almost 4 times faster. But the most important part here is that you reduce the storage requirements by 32x. And this is, I think, is cool because it turns out you don't need all those float information to encode this data accurately. And in the in the ViDoRe benchmark, doing this kind of quantization doesn't really hurt relevancy accuracy. So when you start doing things like this, you have to also evaluate like if there's an impact on the metrics. And then you can use approximate techniques like put this into a nearest neighbor index and do kind of a cascade retrieval or phase retrieval and ranking. So I won't touch on that in detail. You'll find information about that from multiple different vendors of how you can put this together. And also in Vespa, you can do this so that you can scale even to billion scale data sets. So I'll talk a little bit about RAG with VLMs, because with VLMs, you can build an entire RAG pipeline, but the thing is that then you have to have kind of a visual capable LLM for the generative stage of the RAG pipeline. So there you typically use ColPali as your kind of candidate retrieval, and then you retrieve pages, and then you put top K or into the generative model and have it summarize what you can do. Here's an example of a RAG where I used the Gemini AI Studio, uploaded one big PDF. That PDF is like 35,000 tokens, and ask it a question, right? And internally, they're using also the same technique when you're uploading a PDF. They're converting it to images and giving all those images to the model. And nowadays, they have longer context window than before. So if you have a single PDF, you might not, and you can afford it, then you might not have to have ColPali or retrieval stage at all. But if you have many PDFs that you want to retrieve over, then it becomes relevant to filter information and not input everything to the generative state. And also, there's an interesting benchmark called MML long benchmark, and they find that VLMs are better at answering questions about pages and complex pages when they're giving a visual representation of the image instead of going through text trunking OCR pipeline. So I think that's also interesting that they can actually answer questions better when they're giving a screenshot of the page than when they are giving text extracted. Yeah. Some more on the question is more like, does it work for my data, or how does this compare with A, B, C, D? You have to evaluate. Right? The model is snapshot trained on certain specific data that might not match your domain, but there's an interesting direction, and that is to fine-tune ColPali by using synthetic queries. Right? I think, Jason, some of the first tutorial material you had was around synthetic queries. So that's essentially taking your corpus, running it to a capable VLM model, and have it generate questions about the pages, and then use that as the relevancy data to fine-tune the model. So that's how you can go about adapting ColPali or the ColPali architecture to your domain. And better, if you actually have real production queries, you can use that too. And nowadays, with more capable VLMs, it's also easier and also lower cost. It's also easier to generate good relevancy data that you can actually use to tune or fine-tune ColPali for your domain and your type of documents. Can't you use just a frontier model for this? Yes, you can use a frontier model for this, as long as you can fit everything into the context window of that model. ColPali is about taking the capabilities of the VLM and scaling that to larger scale of collections where you cannot really upload everything to the frontier model, right? That's the case. I think it's a very promising direction. I'm hoping to see more checkpoints I'm hoping to see more embedding providers provide embedding models for specific domains, for specific file formats based on VLMs. So I'm hoping to see like legal PDF embedding model based on VLMs, like more general checkpoint. I was hoping for that, but I think Voyage was in that direction, but they got acquired by MongoDB this week, so I'm hoping to see someone else step up. And there are a lot of new VLMs, new models coming out. But of course, this is also, you have to run ColPali, then you have to run it with transformers library. So there's some setup costs. It's not like easily available behind a nice looking API. That's probably the biggest downside of ColPali. But Voya, their latest embedding model, is also able to encode images in a pretty good way of PDF documents, but still not perfect, but it's a step in the right direction, I think. I also have some resources you can check out. I did a lot of content around ColPali because I was really excited about this direction, to be able to search in this information without going through chunking, embedding, and all those messy processes. So I was quite excited there for some time. And if you want to, you can follow me on Twitter. I'm pretty responsive on Twitter. My handle is there. And that's how I got to know Jason as well. Thank you for having me here. I see the chat is full, so I really welcome all questions. I hope I can dig through some of the questions.
Yeah, let's run through some of these. I am curious, even now there's no like single vendor that just allows you to upload a bunch of PDFs and be able to do retrieval, right? It's still quite manual, or have the cloud providers been able to support this?
Yeah, I mean, there are some high level services, right? That's more in the kind of enterprise search, Glean, those type of like more like high level services. And then you have things like unstructured, or that takes care of that part, but not the vector part, not the retrieval part, and not the ranking part. So you have to glue together quite a few things if you want to kind of have control over how you do retrieval and fine tune and re-ranking and business logic and whatnot. So that's the thing you have. If you really need that kind of build that type of thing, then you cannot really use Glean, or they don't give you the option to tune things or adapt it to your domain.
Makes sense. The top voted question, I think you answered this somewhat around just whether or not we can fit everything into context, but with the latest improvements in Gemini, like Flash, for example, and other models, do you think ColPali and these kinds of tools are still relevant?
I think they're relevant because even if there's a lot of use cases that are dead related to RAG because of long context, right? No doubt about it. Single PDF, just upload it to Gemini and do whatever you want to, right? But then there are cases where you have larger document collections. That's the key point, right? If you have millions of PDFs or even 10,000 PDFs, and even if you could fit 10,000 PDFs into the context window, it's also, you pay for the tokens. You also have quite significant latency, even with prefix caching. So I think it's still also relevant for lower volume, but like a couple of PDFs. Yeah, I talked to some company the other day, and they had like 3,000 documents, and I said, yeah, I'm not sure if you need a vector search or a search engine at all for this, because you don't have very strict latency requirements, and the cost is quite low. You don't have a lot of query volume, so why don't you use the prefix feature of the language models? And there's like, okay. Plus, I think with reasoning models as well, you use some of that context window or output as well, that you can fit more instructions and examples and things like that. Yet there's one thing that's for sure. I think the context windows will just increase. So, but I'm not sure if they will increase to web scale data sets.
Yeah. Second question here is, I don't think I know exactly what it's asking, but are there any benchmarks for PDF embedding models, specifically for charts and graphs? I know like Reducto has come up with some models. I don't know if Gemini has like certain evals on reading complex charts and graphs, but I'm curious to hear more about what you think.
I think the ViDoRe benchmark that ColPali introduced is at least one of the benchmarks that includes complex formats. I'm not aware of that many others. other benchmarks out there.
Got it.
Yeah, so you dropping some links in the chat.
Yeah, those will get all put into the same page. Let me see. We have 14 minutes left. Let's do maybe like one or two more questions from the Slido, and then we can go into live questions. So if people want to raise their hands, feel free to do that now, and we'll get to those.
Yeah, that would be fantastic.
Yeah. So what do you think are the main trade-offs of using ColPali? So for example, is it less reliable in some cases? Is it more difficult to verify information in other cases? I'm personally really curious if there's specific industries you've seen that work well with ColPali and ones that don't.
Yeah, so ColPali is a checkpoint in time. I see it. I'm more excited about the direction than the actual checkpoint, right? So the checkpoint is there. It's trained on the data that the researchers gathered. So it doesn't necessarily translate to very legal heavy text or a specific type of financial or insurance reports. And the key there, I think, is to use synthetic query generation and try to fine tune the model for optimal performance. So I would not generalize and say that it works in this and that. It works best for data types that looks like the data that it was trained on, right? So you have to look a little bit in the actual benchmark to see. Sorry for a long-winded answer.
No, it's all very, very helpful. Albert, do you have a question?
Yeah, thanks, Joe. Really love this talk. I had a question about
Thank you.
the future of latent interaction. So I noticed you said that you can create like nearest neighbor index for the images. We're using ColBERT in production, and we do like a BM20 nearest neighbor and then BM25. And at the last stage is ColBERT, but do you see a future where we can do ColBERT? Like, I know it's hard to scale, but could there perhaps be a way to compress the tensor into a single vector? Because you can also fine tune ColBERT, right? And I'm assuming a more granular way of fine tuning.
Yeah, it's a fantastic question. Actually, in the talk, I talked about this embedding model called BGE M3. The unique thing about that model is that they allow you to obtain 3 different representations of the input. A sparse representation, a single dense representation, and a multi-vector dense representation. So with that type of model, it's obvious to use the single dense representation and put that into the nearest neighbor index and do retrieval with that representation, and then use the ColPali signals, the multi-vectors in the re-ranking layer. Unfortunately, that approach haven't really caught my mainstream. But I would love to see more in that direction, where you jointly train both ColPali multi-vector representation or ColBERT multi-vector representation and a single vector representation.
Yeah, I'll look into that. It seems very exciting. Thank you.
Yeah, the M3 papers is worth reading, I think. The only downside there is that they didn't do any kind of dimensionality reduction, so they still retain a lot of float vectors float values for the multi-vector ColPali representations, or ColBERT to be precise.
I guess I'm gonna selfishly ask a question here. Like, when it comes to these kind of joint models like ColBERT, ColPali with these bioencoded models, what company do you think is like, whose responsibility is it to build these kinds of things? Like, maybe it's a Cohere, but I don't know if they do a lot of like PDF processing. Is it going to be like a Reducto and a Llama parse where they're going to own things end to end? I'm really curious what you think about the ecosystem so far.
I think my favorite, I'm not sure if I'm allowed to say that, but I was excited about Voyage, maybe because of the people and the cool name, I don't know. They were going in this direction. There's another that I'm hoping will step up, that is Nomic. Cohere also has embedding models that can accept both text and image, so you can go their route. But I think there's room for more players in this market, and there's to offer this kind of more high-level embedding models for different file formats and domains. So if someone wants to explore that and pitch it to VC, and you can say Joe thinks it's a good idea.
Yeah, I definitely thought about starting something earlier, like maybe in 2023, but the market was pretty tough and pretty challenging then.
Yeah.
Paul's question is pretty interesting. ColPali's paper uses NDCG at 5. Do you
Yeah.
think a ranking metric is a good fit for the task of question and extraction? I think it.
Yeah, this is always a good question. Most of the information retrieval papers focus on precision, and GCG is a precision-oriented metric. You might argue that in the case where we have a generative state, that we should look more towards recall, and are we retrieving all the relevant information? So it's a valid question, I think, but there's usually correlation between those two in some sense as well. And regularly when you talk about recall, it's really difficult as well when you have a large collection, because you don't really know all the relevant information in the index. That's really what, in the information retrieval sense, what recall is about. Do you actually find all the relevant documents that are annotated relevant? But we don't have that luxury in practice.
Paul, I saw that you unmuted. Do you want to follow up?
Yeah, I think maybe you already stated this, but in finance applications where you're really extracting a table or you're interested in a particular cell, NDCG5, it's not, we need the actual table. And for that, there have been these other metrics, tree edit distances. It just seems like in the entire field of extraction, there's different subgroups that are doing very, very different things against different metrics. What do you think of these various camps?
I think so. The ColPali and the metrics there are really focusing about, here's a question, here's a collection of documents. Where are you able, when you're doing the retrieval with this type of method, where are you placing the relevant document in the ranked list? Right? That's all. There's nothing else, right? It doesn't care about if you can actually run that and extract and do another metric. And you mentioned table extraction, things like that. Would be, in my view, in my opinion, for the later stage, right? More in the RAG pipeline, you have retrieve and then you generate, or you retrieve and then you extract, right? So it tries to measure how well just the retrieval part. So yeah, as you said, it's kind of a basic thing, but it's also a nice way of just measuring the retrieval part. And I think that's also important, like overall, to try to measure each of the things that you have in your system, right? You have the retrieval, you have the generative stage. If you have something else, if you have query classification, you could do some evaluation of that, so you can quantify, if I change my query routing, rewriting in this way, does the overall improve or not? And yes, it's complex.
Thanks.
Any more live questions? We've got 4 minutes left. We probably do one more live question before we wrap things up. Well, let me just do one more and then I'll let you go. I see the glass of wine in the background.
It's been a long week.
Nice. So I guess this is a question that might be interesting to hear your thoughts about. Like, what are the best practices for handling things like PII when it comes to this kind of retrieval and representations and whatnot? I don't really have an answer for this myself, so I'm just very curious what your thoughts are.
Yeah, I think that's a really great question. And if I would say ColPali doesn't really care or take care of that at all, right? So that's one of the things where you might want to keep both type of complex pipelines. I know there are APIs from different services that provides this kind of service. I think that's really good argument against not building your entire pipeline only using the visual representations, because the visual representation, I don't know if there are that many services or techniques that can identify PII. Yeah.
I think the security level stuff is something that all these different companies will slowly develop solutions for. Maybe a vendor will pop up in that space. But yeah, I was just very curious about your answer. Cool. I think with that, we can probably wrap it up. Joe,
Fantastic.
Thank you so much for staying up late and getting some questions answered. And yeah, I think it's funny because both your talk and Anton's talk from Chroma all really focused on just like fine-tuning your own embedding models. So I'm really glad that more people are sort of talking about it now. I feel like last year it was very esoteric and maybe scary concept, but now it's been a lot more popular.
That's good to hear. All right. Thank you for having me.
Thank you, everyone. See you next week.
Bye-bye.
Bye-bye.
Thank you.